Alright, so here are the answers to the exercises, and most of them are pretty straightforward, except when it gets to question 2, 3, 2 and 3. And the reason why is because we have a polynomial with two terms as one of the segments. So then you're going to end up with an x squared, right? So this is going to be a quadratic equation. What you need to do to solve that quadratic equation, if you forgot from algebra, is you need to set it equal to 0. So we're going to subtract 18 in this case from both sides, and then we need a factor, right? And when we factor, we're going to have x and x here because we have an x squared, and then you need to come up with two numbers that multiply to c and add up to b. So in this case, 9 and negative 2 multiply to negative 18 and add up to 7. And then finally, we're going to set each of those factors equal to 0. So it'd be x plus 9 equals 0. Solve for x. We'll get x is equal to negative 9. In this case, we'll get x minus 2 is equal to 0. And then we'll add 2 to both sides, and we'll get x equals to 2. And of course, we cannot have a negative distance, so the answer here would be x is equal to 2, right? We're going to ignore the negative value of x. Doing the same thing over here on number 3. So just a couple of reminders that you need to know how to factor in order to properly solve all of the questions in 10.7. Okay, so let me go ahead and move on then. We're here, it's segments intersecting outside of a circle. If segments, secants and tangents intersect outside of a circle, like they do here, then two products are equal, right? And so what two products are we talking about? It's BC times AC is equal to DE times EA. Okay, we got it. Oh, it's right here. So yeah, AC times AB. Oh, I'm sorry. I said that wrong. It's AC times AB, the segment outside the circle, is equal to the entire secant segment times this external secant segment AD. Right? So here it is. Here's another example as well. In this case, we would multiply AB times itself, and then set that equal to the entire secant segment multiplied by the external secant segment AC. Okay. Oh, let me go ahead and fill this out. So here's a secant segment. Is a segment of a secant line that has exactly one endpoint on the circle. So in this case, it'd be AC. Right? It has one endpoint on the circle. The other endpoint is not on the circle. It's outside of the circle. A secant segment that lies in the exterior of the circle is called an exterior secant segment. Exterior secant segment. And what would be the exterior secant segment here? It'd be AB. Right? AB. So the line lies outside of the circle. Another example would be AD. And a tangent segment. Tangent segment is a segment of a tangent with one endpoint on the circle, and so this here would be an example. It'd be AB is a tangent segment AB. Right? Okay, so anyhow, we went over the formulas, and let's go over some of these examples. Example 1, AB is tangent to the circle, and find x. So although BD doesn't look like it, it is a secant segment, and BC is an external secant segment, right? So we have this we have this situation over here. So it would be 18 times 18 the tangent segment squared is equal to the secant segment a dB, which is x plus 15, times the external secant segment BC times 15, like so. Right. Ooh, so I'm going to need a calculator for this one, and it's not going to be pretty. So we got 18 times 18 is equal to 324 is equal to 15x plus, ooh, we got 15 here, times 15, I think that's 225. Yeah, 225. So then we gotta set this, no, we're gonna subtract 225 from both sides. I was gonna say we need a factor, but we don't, because it's not quadratic. This is x, it's not x squared. So I'm gonna subtract 225 from both sides. So I'm gonna minus 225 equals 99. Oh, this is not gonna be pretty. 15x is equal to 99, unless I did something wrong here. Let me double check. 18 squared is equal to x plus 15 times 15. No, this is all right. So then we got 99 divided by 15, 6.6. So I'll say x is equal to 6.6. And we could make this a mixed fraction, but that looks good. So let me go ahead and solve this one. This one looks a little bit simpler. It's going to be, oh, actually we got the same kind of a thing going on. So let's go, the entire secant segment, CL, is going to be x plus 4. And we're going to multiply that by the external secant segment, x. And then we're going to set that equal to the entire secant segment, which is going to be 12, times the external, which is 5, right? Like so. So then here we're going to have a quadratic equation. We'll get x squared plus 4x is equal to 5 times 12, which is 60. Subtract 60 from both sides, we get x squared plus 4x is equal, no, minus 60 is equal to 0. And then we need a factor. So it's two numbers that multiply to negative 60 and add up to 4. So I'm trying to do this in my head. So this is going to be, what, 2 times 30. That's not going to be good. 5 times... No, that's not going to be it. So hold on. Let me... so this is actually a good example on how to factor, right? So we need two numbers that multiply to negative 60, add up to 4. So the methodical way of doing it would be start to 1. So 1 times 60 is equal to 60. Then we'll start with 2. So we get 2 times 30 is equal to 60. Then we'll do 3. 3 times 20 is equal to 60. But they don't add up to 4, right? Or they don't subtract to 4, because one of them is going to be negative, one's going to be positive. So we got to keep going. So we'll go 4 times, what is it? 15. Yes, that's right. 4 times 15 is equal to 60. We got 5 times 1, 2 is equal to 60, 12. We got 6 times 10. Oh, that's a good one. 6 times 10. So 6 times 10 that subtracts to 4, right? Because one of them is going to be negative because of the 6. So that we found it. So then that's it right there. Right. Anyways, this is the methodical way of factoring a quadratic equation. So we'll say x, and then now the question is which one's going to be negative, which one's going to be positive? Well, they add up to 4, so the 10 is going to be positive, the 6 is going to be negative. So plus 10 minus 6. And then we set them both equal to 0, so x plus 10 equals 0. Solve for x, x is equal to negative 10, and also positive 6. Of course, we cannot have a negative distance, so our answer is going to be positive 6. So anyhow, that's this portion of problems, and go ahead and complete these. I'll show the answers in the next video.